In this video, we present Chuck, a one-handed technique for sharing documents between private devices and public displays. Chucking is based on the natural human gesture used for throwing or passing objects between members in different settings. In addition to sharing images, chucking can also be used to share a variety of objects, for example documents, contact information or business information such as email, and for presentations. Chucking is meant to address one-handed use of personal devices, letting the user carry out other tasks with a free hand. Increasing number of personal devices such as cell phones and PDAs are now using built-in tilt sensors. Current devices are reducing the need for a stylus in favor of finger-based touched input. Here's an example of a cell phone with tilt sensor. The sensors together with touch input make for an ideal platform for gesture-based, one-handed interactions such as chucking. We're also seeing a widespread usage of tabletop displays and large wall-mounted displays in commercial, business, and educational settings. Other techniques exist for private to public display coupling, such as flicking, which involves the user placing the stylus or thumb on the object and flicking in the direction in which to send the object on the large display. Flick relies on stylus use and has not been adapted well enough to support one-handed interaction. Flick also requires more screen space and is limited for certain parts of the screen. Chucking is meant to address effective utilization of screen space on small devices, in contrast to techniques such as flicking, which require substantial screen space to perform the flicking motion and is limited by the device's bezel or if the object is in a corner. We now present additional techniques that extend chucking. Chuck and rotate. The user performs a chucking gesture to send the picture across to a large display and then can use the thumb to rotate the picture clockwise or counterclockwise. Chuck in place. The user chucks the picture to a large display and then can accurately position the document anywhere in the XY plane, regardless of the grid, by holding down the picture until placed where desired. Chuck back. In chuck back, users are able to retrieve objects from the public display and place it onto the private device. Upon hovering the cursor over an object, the user can then initiate a pullback by making a motion in the direction opposite of chucking. Error rate. Among the total of 4,000 experimental trials split in half for each technique, users performed an error on 342 trials with chuck, yielding an error rate of 17.1%, and 686 errors with flick, resulting in an error rate of 34.3%. Meantime, on average it took participants to complete a trial in 777 milliseconds with chuck and 352 milliseconds with flick. It is not surprising that flicking took users less time to complete, given finger movements are known to take much less time than full arm movements. Failure rate. After 5 attempts, we ended the trial and recorded it as a failure. Overall, participants failed on 20 trials with chuck for a failure rate of 1%, on 88 trials with flick, resulting in a failure rate of 4.4%.